So today's class will be based on introduction to solid state. Okay, so what is solid state? How do we understand? How do we differ it from the other states of matter? So all the discussion, different types of solids. Okay, how do solids, or what are solids made up of? What are their constituent particles? What is the binding force? Okay, what are their characteristics? So all this different types of concept we'll be learning in this particular class. Okay, so starting with the introduction. What is a solid state? A solid state is defined as that form of matter which possesses rigidity and hence possesses definite shape and a definite volume. So there are few things which makes a state a solid state. We know that any particular matter exists in three basic states, that is solid, liquid, and gas. But not only that, it exists other than solid, liquid, and gases. We have other states of matter. But if you try to distinguish them, that what is a solid state and how does it differ from the rest of the state? A solid state is basically that form of matter which possesses rigidity, okay, which is rigid, and hence possesses definite shape. Okay, the shape does not change so easily, and hence a definite volume. So if you have a rigidity in your state of matter, if you have definite shape, and if you have a definite volume, they are nothing but solid state, which you can see in the pictures. They are all solids. Okay, they have a definite shape, they are rigid, and they cannot be just actually changed into another form. Okay, and they have a definite volume. Okay. So what are the characteristic properties of a solid state? So if I say a solid state, what are the characteristic property? How do I know that, okay, this is solid? Okay, this particular state is solid. So if you want to know that a particular state which you are trying to assess is a solid, you need to have these characteristics. What are this? They have definite mass, volume, and shape. So the mass, volume, and shape has to be definite. Intermolecular distances are short. You can see in the figure also the molecular distance. Okay, the intermolecular distance, the distance between the two molecules have to be very short. They have to be very, very close. What we call as close packing in solids. They touch one another. They are that much close to one another. Okay, intermolecular forces are very strong. Since the intermolecular distances are very short, so the intermolecular forces will be very strong. They will be holding one another very tightly. As a result, they will have very high rigidity. They will not be having, or they will be having a definite volume. Okay, they cannot be moving here and there. They will not be moving in different directions. Okay, they will be fixed in one particular position. Their constituent particles, okay, when we say constituent particles, what do we basically mean is what they are made up of. Okay, they can be made up of solid, they can be made up of, they can be made up of ions, they can be made up of molecules or atoms. Okay, whatever they are made up of, they always have fixed position. What I have told you, you can see in the figure also that they are having fixed position. They cannot just move, but that does not mean they are perfectly static. They are not static. They are having, or they can oscillate about their mean position. Okay, so they can oscillate. All the molecules, all the atoms, or whatever the ions are present over there, they can oscillate about their mean position, but they cannot just have a random movement. Okay, just vibrations or oscillation about their mean position. They are incompressible and rigid. You cannot compress it, and they are rigid. So if you see this characteristics in any states, then that particular state is nothing but a solid state. Okay. And the next is type of solid. So what are the different types of solids which we have? So if you take a broad classification, solids can be categorized into two categories, which we call as crystalline solids and amorphous solids. So what is the basic difference between crystalline and amorphous solid? How you can say that, okay, this is crystalline and this is amorphous? By looking into a particular substance, we can never say that this is crystalline and this is amorphous. Most of the times we go wrong. So the crystalline and amorphous is based on the arrangement of the constituent particles. Whatever is the constituent particles it is made up of, if the internal arrangement of the constituent particles are definite, ordered, regular, then it is crystalline solid. If the arrangement is not regular, it is irregular, it is not definite, they do not have any well arranged geometries, then such solids are known as amorphous solids. So remember that the basic difference between crystalline and amorphous solid is on the arrangement of the particle, not on the appearance. It is the arrangement of the particle which decide whether it will be crystalline or amorphous. If the particles are well arranged, ordered, definite geometry, regular arrangement, then they are crystalline. If it is not so, then they are amorphous. Going for crystalline solid, it will have a long range order. That means those arrangements, what you'll have, the definite geometry which you'll have will be for a long actually distance. It will not be for a short distance. Okay, that is what we call as long range order. Okay, you can see in the screen that it has a long range order, which means that there is a regular pattern of arrangement of particles which repeat itself periodically over the entire crystal. So that arrangement which the constituent particle is, or that particular pattern which the constituent particle is making, that arrangement will repeat and go on and go on and go on, and it repeats over the entire crystal, over the entire solid. The same arrangement you can see over the entire crystal. The same thing you will not be able to see in amorphous solid. Amorphous solids will have regular arrangement, but only in a short range, only in some well-defined or only in some small places or in a very small region of space. You'll find out that they have a arrangement, proper arrangement. Then in rest of the space, you'll find out that they are not properly arranged. That's why we call them, they are short range order. And one thing you remember, this small arrangements, okay, in amorphous solid, which resembles to a crystalline solid, we call them crystallites. Okay, so it is not that amorphous solid is completely disorganized, completely irregular. There are some portions of amorphous solid which resembles to a crystalline solid. They are ordered, but only for a short range. So this short range order, okay, whatever they have, this arrangement for short range is known as crystallites. Okay, coming for crystalline solid, crystalline solids are anisotropic in nature. Very, very important. What is anisotropy? Remember that when we say anisotropic in nature, some of their physical properties like electrical conductivity, refractive index, etc., show different values when measured along in the same direction in the crystal. This arises from different arrangement of the particles in different directions. So what they are trying to say is, whenever you say actually take a crystalline solid and measure some physical property like electrical conductivity, refractive index, thermal expansion, if you measure it in different direction, in the same crystal, but in different direction, you will not get the same value of those properties. You'll get different values in different direction. The same thing, if you measure in amorphous solid, what you get is, you measure in any direction of that amorphous solid, you'll always get the same value of that particular property. Such phenomenon in amorphous solid is known as isotropy, whereas in crystalline solid, it is known as anisotropy. To explain that, let me just show you one particular figure. Okay, so just say this particular figure. Okay, this is a crystalline solid and this is amorphous. So that is what I was talking about. Can you see that in crystalline solid, how well arranged it is? You can see a definite geometry being made by the particles, right? And it can go on. Try to understand that it will just go on along the entire stretch of that particular crystalline solid. Okay, so this type of arrangement where you can see that it is forming a regular pattern of arrangements. Okay, particles are actually very close to one another, well-defined structure. But the same thing when you see amorphous solid, can you see the particles are not actually the same? Some particles are in some other distances, some are far, some are very close. So the arrangement is disordered. Yes, there are some arrangement which you can find which are quite resembles to the crystalline solid, but it will be only for a short range. But the same thing in crystalline solid will go for a very long range. So that's the basic difference. Okay, that is how we can picturize it. The figure which you can see below, is the anisotropy in crystalline solid. See, what we are doing is we are taking a crystalline solid. You can see a very well arranged arrangement, right, of particles. There are two kinds of particles which are shown by two circles. One is with blue and one is with red. What we are trying to depict over here is the particles are arranged in a very regular fashion. So when it is arranged in such a regular fashion, what happens is when you move in two different directions, so we are taking two different directions, AB and CD. So when you move in the direction AB, can you see that the particles which you are encountering are blue or only the red ones? Is it not? But when you move in the direction CD, can you see you are getting different types of particles? Means you are getting the red ones also and the blue ones also. So what we are trying to say is, because of such arrangement, that when you move in different direction, you are getting different types of particle, as a result of which the physical property, if you measure in the direction AB or if you measure in the direction CD, it will be completely different. Means the value will be different within the same crystal. Okay, it is the same substance, everything is same. But when you are measuring the same property in two different directions, you are getting two different values. It's because of two different kinds of particles which you are encountering when you are moving in two different directions. Okay, it is because of the different types of particle which you encounter in different direction in crystalline solid. The same thing when you see amorphous solid on your right hand side, what you can see is the particles. Can you see there are two different types of particles, but they are arranged in an average. The number of particles which you are encountering in two different directions are almost same. Why? Because the particles are not well arranged. When the particles are not well arranged, you will not encounter different types of particles in different directions. You will encounter the same type of particle. When you will encounter the same type of particle, what will happen is when you measure the property, obviously it will always come out to be same. So such phenomenon is known as isotropy, and such phenomenon in crystalline solid is known as anisotropy. So whenever anyone will say anisotropy, what do we mean is it is nothing but the value. If you measure the physical property value in the same crystalline solid in different direction, you get different value. But the same thing when you measure the physical property in two different directions in amorphous solid, you always get the same value. That is isotropy. Okay. Coming for the next. In fact, crystalline solids are true solids. Okay. So remember that only crystalline solids are regarded as true solids, whereas amorphous solids are not considered as solid, but they are considered as a supercool liquids. Okay, a very high viscosity, and are called pseudo solids. So remember that the word pseudo, what do we mean, is false. Okay, so whenever we say solid, so what basically we mean is always crystalline solid. Amorphous solids are not considered as solid only. What they are considered as supercool liquids. A liquid which is super cool means which cannot move, and it will have a very, very high viscosity. Remember that when we talk about this viscosity, viscosity is a property of a liquid, not of a solid. The question is, how do we prove it? Why only crystalline solids are considered as true solids? Why not amorphous solids are considered as solids? Why they are considered as liquid? And why we are talking about viscosity? This is supported by the fact, okay, if you see window panes of old glasses, okay, old glass or old houses, okay, if you see this glasses, okay, like what is shown in a figure, if you see such kind of window panes, okay, what will be found, or if it is preserved, well preserved for, let's say, for a number of years, okay, very, very old houses, it was found out that the glass, okay, the window panes, obviously it will be everywhere, the thickness will be same. When you take a window pane, it will be of same thickness on every side of that particular, or on every part of that particular glass. But when you keep it in such position for a long years, 10 years, for 15 years, 100 years, 50 years, what happens is the lower portion of the glass, okay, this portions, it was found out to be thicker than the portion which are above. That means this portion are thinner and the lower portions are thicker. How that can happen? It can only happen if this particular molecules in this glass are flowing. Okay, they are not static. They are flowing, but yes, it does take time. It will not happen in 1 day or 2. It will take a very, very long time, but slowly, slowly, the glass molecules from the top will slowly, slowly flow down. And once they reach the bottom, obviously the bottom will become thicker than the above portion of the glass. So that's why we say that glass possesses actually a character of a liquid. Okay, although it looks like a solid, but it is not a true solid. It is a supercooled liquid. Okay, it may also be noted that window glass of old buildings. Okay, if you see old buildings like this, you can see over there in the screen also that it looks milky. It's not transparent, no, clear, transparent. We usually, which glass are very transparent, right? Very clear. But this, you can see it's not clear. It's kind of a milky, it's kind of opaque, actually, what actually we can see. So why this happens? It was found out that this is because due to heating during the day and cooling at night. So what happens to this glass? Obviously, it faces the sun whole day. Then at night, it cools down again. Again, tomorrow morning, again, whole day sun, and then again cools at night. So this process goes on, okay, cooling and heating, cooling and heating. If it continues, this particular process is known as annealing. Okay, and because of annealing over a number of years, this glass acquires a crystalline character. So basically, the amorphous solid is turning into a crystalline solid. Okay, so that is how we can understand the very basics of solid state. Okay, so whenever we talk about solid state, what is a solid state? A solid state is basically a state which will have rigidity, which will have a fixed volume, which will have a fixed shape. Okay, we have seen the characteristics of solid state. How many types of solids are there? There are 2 types of solids, which we called as crystalline and amorphous. Okay, and what is the basic difference between crystalline and amorphous? Crystalline solids are those solids where the arrangement is ordered, whereas in amorphous solid, the crystalline arrangements are not ordered. In case of crystalline solid, the particles actually are well arranged for a long distance over the entire stretch of the solid, which we call as long range order. Whereas in amorphous solid, we have the short range order. Amorphous solids were found to be isotropic in nature, whereas crystalline solids were found to be anisotropic in nature. And what we found out at last is amorphous solids are not considered as true solids, but are considered as pseudo solid, which is basically means false solid. Why? Because it was found out that amorphous solid do possess some fluidity. Okay, they flow. Okay, and amorphous solids, okay, like glass, when it gets heated and cooled continuously, that is annealing happens over an entire or over a number of years, then it was found out it tends to convert to a crystalline solid. It goes for some character of crystalline solid. So that is how we can understand the very basics of crystalline and amorphous